You already made a prediction, but let's review it. Here you have a cylinder with a piston inside it. If the gas inside the cylinder and outside the cylinder are both at 30 degrees Celsius, would you expect the piston to move up or down as a result? So the gas within the cylinder is this gas here. That's what it's referring to, the gas under the piston. And then the gas outside the cylinder, yes, it's this area out here, but it also is this area right above the piston. So if the temperature above and below the piston are the same, then that means that the kinetic energy of the average kinetic energy of the air molecules are the same. So the air molecules are striking the piston from the top and the bottom with the same amount of energy and with the same frequency. And so the piston won't move up or down. If you have a difference in the temperatures between the inside and outside of the cylinder, then if the temperature is higher inside the cylinder, the piston will move up. If the temperature is higher outside the cylinder, then the piston will be pushed down, assuming that the amount of gas inside the cylinder stays the same. And by amount, I mean the number of molecules. There's no valve letting air in or out. Let's look again at a system diagram. Here we see the system represented by the dotted line. We see heat entering the system from an area of higher temperature, and then it flows down out of the system to an area of lower temperature. But in the process, there is work being done. This diagram, this system, this dotted line represents a heat engine. Excuse me, a heat engine is a device that transfers some of the heat as it flows from higher temperature to lower temperature, transfers some of the heat, transforms some of that heat into usable energy so it can do work. An engine takes in energy in some form, maybe it's chemical, maybe it's heat, thermal, but it takes in some kind of energy, and there are different kinds of engines. It's going to take in energy in some form and it's going to give off mechanical energy. So it's going to do work. And it's not going to be 100% efficient. So some of that energy is actually going to move right through the engine without becoming usable, without doing work. So this cycle is used in steam engines. Steam engines use water vapor as the fuel. Even a water wheel changes potential energy, uses potential energy of the water to do work, or the kinetic energy, depending on how it's structured. A steam engine is an example of a heat engine. A heat engine has heat as an input and work as an output. But again, unless it's 100% efficient, it's not going to just have work as an output. And engines are never 100% efficient. In fact, they're not super efficient at all. Most of that heat just goes right through the heat engine. That's why cars um, get hot. So here we see a water wheel. This is one type of water wheel where the water flows from a higher point to a lower point, and as it flows, it turns that wheel. So it goes from higher potential energy to lower potential energy. And as it turns the wheel, the motion of the wheel can be used to do work. It's using both the kinetic and potential energy of falling water in this case, because the water is flowing, so it has kinetic energy, but it's also falling, so it's decreasing in potential energy. Some water wheels will just dip into a river, and the river will flow by and turn the water wheel instead of falling from above. And in that case, you're really mostly turning it with kinetic energy. A water wheel of this type uses a difference in gravitational potential energy to do the work. Again, it's an energy difference. Okay, keep that in mind. It's an energy difference. We go from an area of higher energy, in this case, higher potential energy, to an area of lower potential energy. And that energy That energy difference is used to turn the wheel and do work. We're going to see this idea of energy differences come up again. A heat engine takes in heat, so it has an input of heat, and then it has an output of work. But again, it's not 100% efficient, so it actually has an output of heat and work. Uses a difference in temperature to do work. Heat enters the engine from a high temperature area, it flows to a low temperature area, and and somewhere the engine has some kind of a structure that also uses that energy flow to do work. A heat engine and a heat pump is well, those are two kinds of practical systems that use these cycles to transfer energy between areas of high temperature and low temperature. Heat pumps can be used to cool a building, for example. They can pump heat out of the building and help cool it off or warm it up, depending on how they're designed. Engines have a lot of waste heat. If we can reduce this waste heat, we make the engine more efficient because you get more work for this you get more work output for the same energy input. So it's important in an engine to try to reduce the amount of waste heat.